Hey fellow scholars, this is Sherri Tech. This reading session presents a unified pretraining framework for document understanding published by Adobe. In the real world, documents often contain important visual formatting layout information and features such as tables, figures, and charts that have their own local semantic properties. This information and the hierarchical structure and context-dependent nature of such documents are not fully exploited in current natural language processing models. Adobe presented a pretraining framework for key information highlighting in both visual and textual content. This framework has led to better performance on many downstream tasks such as form understanding, receipt understanding, document classification, and document object detection. On the task of form understanding, it requires the model to predict whether a given semantic entity is a question, answer, header, or other. This paper achieved 87.93 F1 score, which is about 3% improvement compared to existing state-of-the-art models. On the task of receipt understanding, it requires the model to recognize 30 types of entities under categories of company, date, address, and total. This paper achieved 98.94 F1 score, which is about 1% improvement compared to existing state-of-the-art models. On the task of document classification, it requires the model classify documents into classes such as letter, email. This paper achieved 95.5% accuracy. However, this is marginally lower than one of the existing models. On the task of document object detection, it requires the model to decompose a provided document in image format into semantic units. This paper consistently outperformed the existing models on classifying text, title, list, table, and figures. So now you may be wondering, how did they achieve this? The framework is made up of feature extraction, feature embedding, multi-layer gated cross-attention encoder, and pretraining tasks. In feature extraction step, the framework adopts off-the-shelf Ochre tools such as Tesseract, Easy Ochre, Google Ochre, and Microsoft Ochre to extract words, sentences, and bounding boxes. For feature embedding, UDoc combines the textual embeddings and position encodings to generate multimodal embeddings. Namely, given the output of the previous extraction step, the framework takes image regions and words that correspond to each document elements as inputs, and extracts their respective embeddings through a visual feature extractor and a sentence encoder. These visual feature and language feature embeddings is then fit into the multi-layer gated cross-attention encoder. The multi-layer gated cross-attention encoder is a transformer-based encoder that integrates the embeddings of visual features and language features from previous steps together. The model is then pretrained with 3 tasks: masked sentence modeling, vision language alignment, and visual contrastive learning. The masked sentence modeling task is similar to the pretraining task of BERT, except that the sentences are masked instead of the tokens. In such task, given the unmasked words and visual features, the goal is to predict the masked sentence embeddings based on the contextual information from the surrounding sentences and image regions. The second pretraining task is visual contrastive learning. This is learned by estimating the visual representations of masked regions and compare it with the set of candidate representations. The representation is learned by maximizing agreement between output representation and actual quantized representation of the same regions of interest. The last pretraining task is vision language alignment. This task aims to enforce the connection and relationships between image and text features via similarity-preserving knowledge distillation. The minimization objective is the difference between pairwise similarities of sentence embeddings and pairwise similarity of image region features. Even though the paper has proven to achieve major accuracy improvement on a few document understanding tasks, the paper did receive a few criticisms, one of which is concerned with originality. This concern was raised because most of the parts of the model are largely borrowing from existing work. However, the author argued that pretraining framework itself is novel and beneficial to the field. This concludes the reading session. Does this get your mind going? Let me know in the comments below.